I think it's time to get going, right? Thank you again. We're down to our last two official sessions with BSides before everyone adjourns to the bar downstairs, or not everyone, but those that want to. If for no other reason, you could warm up down there just by going outside. It is cold in this room. We're doing all we can to try to mitigate that. I'm going to repeat only because thanking USAA and St. Mary's in particular for making all this work is really important to us. So I'm going to say it again. Thanks to them. Thanks to all of you for coming out and joining in. And believe it or not, on a June day in San Antonio, braving the cold to come to this session. I know Alex likes it cold. He's in his element right now, which is good for him. I want to thank Spectre Ops, who happened to be the presenter for the last session, but also a sponsor that I failed to mention last time. So if you were here for that, let Josh know I did mention his company. And we are now going to hear about quantifying breach impact mitigation by Zero Trust. And the speaker is someone that I've known, I guess, 4 years?
4 or 5 years.
Yeah, it was during COVID that we met. Alex Malashev is very well versed. He's done a bunch of great things on this, and I know you're going to enjoy this session. I know he's going to enjoy it. So Alex, please take it away.
Thank you, Jeff. Hi, everyone. Thanks, everyone. My name is Alex Malashev. I go by Alex. It is Alexey, though. But I do want to do a quick introduction for myself. So I have about 20 years of experience working in IT across multiple fields in the industry. So I work for weapons development companies, nuclear energy companies. I've also worked for small businesses here in San Antonio, managed service providers, U.S. courts, administrative office of U.S. courts. So I really have diverse experience across all fields, all possible walks of life for IT specifically. Jeff actually was my instructor for CISSP exam about 4 or 5 years ago. Passed the exam. Since then, I've been working for ZTA and now working for Philips as a senior cybersecurity manager for product security and services, mostly supporting government contracts because government is what I know best probably. I graduated from American Military University with a 4.0 GPA with a Master's in Information Assurance. And since CISSP, I've probably gotten just about every single security certification I could get my hands on. CISM, CCSP, pen test. Again, just a huge nerd, like to play with computers, like to code, like to break infrastructure, which is kind of the reason for this presentation and what led me to this experiment in general. So first, I want to cover the agenda. For the agenda, first we're going the mission statement, and the mission statement is important here because we all know how horrible scope creep can be within projects. By defining the mission statement, we define our parameters for our experiment and make sure creep does not occur, or at least we control it to a certain extent. Then we're going to go into the introduction to Zero Trust framework. This is going to be really high level just to make sure everyone understands the difference between Zero Trust and the typical network segmentation, traditional network segmentation. Then we're going to talk about microsegmentation as one of the ways or one of the tools to achieve Zero Trust architecture within our environment. I'm going to go over some of the slightly outdated stats at this point. They're between 2021 and 2023 for the current state of cybersecurity, cost of breaches across globally as well as nationally, and how mature, how well implemented Zero Trust architecture into current IT infrastructure globally. Then we're going to go over the experiment design, the experiment limitations, kind of go over the lab configuration or lab environment configuration, and finally on to results and the final tips and takeaways. So first of all, the experiment goal or mission statement. So the goal was to evaluate microsegmentation as a standalone control. Why am I looking at the microsegmentation? Because microsegmentation is at its core of Zero Trust architecture. The way we achieve Zero Trust is we ensure that every flow or every connection is verified and is explicitly allowed. This microsegmentation is a great tool or a great way to make that possible because it allows us to submit and control flow across infrastructure down to very granular levels, down to user and applications and exactly which protocols are allowed to talk to what resources on the network. So what is Zero Trust? Zero Trust is a security model. It is not a tool. It is not a thing you buy out of the box. It is a security framework and it is a model. It relies heavily on enhanced identity governance. So we need to be able to identify all of our resources on the network, and we need to identify and allow them access to the resources they need to access. The difference between So microsegmentation is one of the tools can be leveraged to employ zero trust architecture. And in this specific case, I was using software-defined networking for my microsegmentation tool, specifically VMware NSX 4.0. It does require continuous monitoring of the entire infrastructure, analytics of logs and access and network flows. And relies really on principle of least privilege at its core. And I know the principle of least privilege has been around for, well, as long as the computer security existed. But Zero Trust really takes it to the next level and it allows only exactly what is allowed versus blanket statements or open or implicit allow rules. So why is microsegmentation different than traditional networking or traditional network segmentation? So microsegmentation separates our data plane and control plane into two separate mechanisms. And the control plane controls the access and the routing through the environment, whereas the data plane controls the actual data packets and the actual information that reaches those systems. The reason why the separation is important is because with these microsegmentation, we have 24 bits reserved for the virtual network identifier. 24 bits for the VNI means we have over 16 million possible segments that can be created. This is exactly what allows us to create those small segments and small policy and control rules. Who can talk to who versus, for example, if you're talking about layer 2 switching, 802.802.1q reserves only 12 bits for our for the VLAN ID. That only allows us 4,000 possible network segments for the layer 2. Layer 3, obviously, it's a little bit more, but then there's also all kinds of rules and which IPs can be allocated for what purpose. IANA controls the public IP space, and also you have to give up the number of networks you can deploy versus how many hosts each network has. From the segmentation perspective as well, typically with a layer 2, you end up controlling it at choke points. With microsegmentation, it's controlled at an interface level. So basically, any device or any object that connects to the network can be isolated independently. And last but not least, specifically with the software-defined networking, we have full layer 7 integration. VMware NSX integrates into Active Directory. It integrates into layer 7 of the network packets, so we can build our policies and our flows based on very granular and very specific rules that are dynamically updated as well. So you don't have to have a network admin sitting there filling in these ACLs, constantly updating them every week or every day when a new user comes on board. So the current state of zero trust architecture, first of all, between 2021 and 2023, the number of breaches has increased by 30% year over year. COVID probably had a huge portion to play to that. In 2021, I was actually working as on an incident response team for a managed service provider. I think I responded to 4 or 5 incidents in the first 8 months of COVID, of the initial lockdowns. So COVID did play a large role in the increase of the incidents, and IT wasn't prepared for this. At the same time, if we look at the zero trust implementation across industry, We see Beata's report, and it's a self-report. It is a survey, so take those results for what you will. But the self-reporting showed that in 2021, 35% of companies employed zero trust architecture versus 61% of companies in 2023. So the number of organizations deploying zero trust architecture has doubled. At the same time, if you look at the cost of cybersecurity breaches between 2021 and 2023, it has only increased by 2% year over year. So we have almost 3 times more incidents happening between 2021 and 2023, but the cost has only gone up by 4% over those 3 years. We have gotten better responding to incidents, but I do think that zero trust architecture it has played a part in it. And as we go through this experiment, through these practical analysis of how effective micro-segmentation mitigating the impact, we'll see why I do think that there is a big correlation there. So first of all, the experiment design, this is going to be the infrastructure. The infrastructure itself, I'm running a 3-host VMware cluster with an SXT 4.0 with GenAV overlay software-defined networking. GenAV is the new overlay SDN protocol that is going to be the standard that's being implemented in Cisco. Before, there used to be a VXLAN and VGRE were the previous protocols. There was a lot of compatibility issues, so now the industry is switching to GenAV as a standardized protocol across the industry. I'm also running on-premise Splunk server, so I'm using Splunk for the data, for the log analytics and for visualization. Primarily, right here at the bottom is the infection monkey reporting graphs. You can see they're completely useless, so I opted for Splunk to code to write out my diagrams and analyze the traffic as it flows through the environment. Infection monkey is what I'm using for the breach simulation utility. Again, it's an automated breach simulation, so you basically point it towards a network. You say which exploits you want it to run, and it runs through the environment, compromising systems one by one that it has access to. Resources within the environment are built based in alignment with a typical role-based access control model. So we got our desktop users, we have our help desk users, our server admins, database admins, domain admins. Users are randomly generated with a PowerShell script, 5 domain user groups. So we have the desktop, help desk, desktop users, HR, finance department, and server admins. The environment is going to be rolled back between every single test using snapshots. Again, everything is scripted and automated to make sure we eliminate as much variance as possible. Also, I'm lazy. I don't like clicking on stuff that often. All nodes do ship logs to the Splunk system. Once again, analyzing logs through Splunk is just a whole lot easier than trying to go through the systems individually and try to aggregate them through an Excel spreadsheet. Each user, this is going to be one of those things that I know most cybersecurity folks will frown upon, but each user is going to be an admin on their own desktop. While it's not the best practice, I do see it happen quite often, and this is typically the result of a lot of breaches. Overall, we have 36 systems on our network. We have 2 domain controllers, 2 IIS servers, 4 file servers, 3 financial database servers, 3 HR database servers, and 5 desktops for each type of user. So for financial users, they have their own desktop. HR has their own desktops. The test is conducted in 2 separate phases with multiple scenarios tested. So the first phase is going to be completely unsegmented, so your flat typical network. I will say that technically there is going to be a layer 3 segmentation. They do have different subnets created for all of them, but there is no ACLs. I'm not controlling any traffic between those subnets. So you might call it segmented, but it's not. There is really no ACLs across the board. The second phase is going to be a segmented test. So this is going to be enabling our software-defined networking default rules switch to deny versus allow. That's all it does is it enables our security groups and controls of those flows. The controls and flows in an unsegmented section are going to be still set up and controlled, but the default rule is going to be applied or allowed. And that's actually what allows me to see the network movement through the network using my NSXT as well as the Splunk infrastructure. Hardware, again, this is just more for hardware nerds because I'm one and I get excited when I see hardware in home build labs. So I'm running 3 super micro servers, 512 gigs of RAM on each. Everything is running VMware. The storage is delivered using vSAN, so VMware's hyperconverged offering for the storage. The vSAN itself is all flash. Not expensive whatsoever. This is the eBay drives for $35. It did take me a lot of work to make it work within the VMware environment because they don't like unsigned drives, but I also wouldn't do it in the production for sure. This is a home lab only. The fabric itself, the fabric for the storage is delivered via 10 gig fiber switch, MikroTik, with 2 bonded cards, so 20 gig uplinks across all the storage. And host-to-host networking is done with the bonded network cards with a 1 gig managed switch. Again, MikroTik, so 2 gig backbone for server-to-server communication or host-to-host. This is the network layout, network topology. So fairly basic, fairly straightforward. We got the tier 0 router. Tier 0 router up here at the top, that's our off and on ramp into the physical infrastructure. Over here to the side, can barely see it because of the brightness, is where the Splunk server sits. I call it the audit domain or the audit subnet. And the tier one router is where the remainder of the infrastructure sits. This allows me to separate the traffic within my home environment. Again, this is a home lab environment. There is a lot more infrastructure around it, but this is how I segmented it and separated it from the rest of my lab. I guess shenanigans you want to call them. One thing I do want to point out is I do have an NSX IDS deployed and turned on. I did turn it on. I did turn it into an audit mode specifically for this test because I want to see whether IDS is going to be triggered easier or harder the deeper, the more complex attack path is within the environment. To no surprise, that was the case. But I did turn it off because I also didn't want to interfere with the test and actually test the microsegmentation as a standalone control. So the scenarios we're going to be testing is going to be unprivileged user compromised, desktop privileged user compromised, server privileged user compromised, and a domain admin compromised. I know when we hear domain admin compromised, we think that's it. Everything is over. We can go home that day. And honestly, I would agree with it. If I was dealing with it, that's not a scenario I want to deal with. But in these tests, you'll see that microsegmentation does prevent a lot of the impact, even in the worst case scenario. So from the reporting perspective, Infection Monkey is used for the initial report or the initial log analytics, but then Splunk is what's really used for the final analytics and the graphing and the visualization of all of the attack paths. And then the impact score is calculated. So the impact score is calculated based on the depth of the path required for an attack to reach a system, as well as whether the system was compromised or not. So the deepest possible path within this environment is 5 hops. So each system can have a value of 5 points. For every hop to reach that system, for every hop to reach that system, 1 point is subtracted. So if the system is compromised in 1 jump, it's a 5 point. If system compromised in 4 jumps, that's a 1 point compromise. The exploits I enabled within the Infection Monkey are going to be the PowerShell exploiter, WMI exploiter, and an SMB exploiter. Again, I know this environment. This is a Windows environment. Everything is going to be 100% Microsoft based. There was no reason for me to run 50 different exploiters with tests because they do take quite a bit of time to run. So I'm trying to optimize this test. So experiment limitations. This is a biggie. I'm using Infection Monkey as the breach automated simulation tool. What does that mean? It's a script kiddie. This is not going to be your advanced persistent threat or somebody who hacks your environment and sits in there for months on end. This is going to be a kid clicking on scripts and running them across the environment. To enable reporting, one of the big things is to enable the reporting within the environment. I do still allow each system to talk back to the command and control center. That will not be the case in a true zero trust infrastructure. You will not allow those outbound connections unless they're verified. But in this scenario, specifically for this test and the experiment solely, I did allow it because I wanted the reporting to be accurate. And one point that's a really big point actually, defense in depth is considered during this test, but it is not implemented. That takes me back to that comment about the IDS, IPS being disabled in the environment. If the defense in depth is implemented, that will greatly increase the efficiency of zero trust architecture to prevent breaches. Or not necessarily breaches, but at least the spread through the environment. So this is the overall results. For the overall results, we can see the scenario column, HR account only, help desk, HR and the server account compromised. And the compromises, the scenarios are working in stages. So initially you will have, let's say your HR user's compromised credential, and the attacker gets foothold into the HR systems. Well, then they can use tools like Mimikatz to scrape passwords of the HR systems, and if there is a cached password for one of the other domains, that could potentially. If we're with the scenarios. If an HR user is compromised and a credential for a server admin, for example, is cached in one of the HR desktops, then the attacker can steal the credential, scrape it, and then use that, pass it to the remainder of the infrastructure for the compromises. So these are the scenarios I'm testing. I'm trying to keep them to what realistically happens in the real environment. Hopefully, we're not posting our domain admins' passwords on forums so that they're not going to be directly compromised. It's typically going to be a scraped credential that gives the attacker access into those privileged resources. I'm also limiting the column of number of exposed systems. We'll specifically say how many systems are potentially can be compromised with each scenario. So with the help desk only, the help desk user has admin rights on 20 desktop users. So therefore, there is 20 exposed systems in this scenario. Segmented total score, so that's going to be, or segmented total compromised. That's the number of systems that were compromised in the segmented scenario. This is going to be the number of systems compromised in an unsegmented scenario. The segmented impact score, so this is going to be the scoring. Unsegmented impact score, fairly self-explanatory. And then the percentages. So the percentages are just the percentages of the total exposed. And finally, the delta. Delta is what we're really looking for to identify. What's the difference between a segmented or a non-segmented compromised scenario? So at the high level, at an overall, we can see the median unsegmented compromise was 95%, whereas the median impact score for the segmented test was at 20%. That gives us a delta of 75% and an average delta of 61% between 32 and 94%. So that's significant. But there is a couple things that I do want to point out. With some of the scenarios, and domain admin scenarios I'm going to show, the delta is very large. So the delta is going to be significant. However, that doesn't tell us the true story. Just because we have only one system compromised, like a domain controller, that means we don't have a domain controller. That's the whole environment, basically. But it could play a role in recovery or in the recovery stages of your incident. So this is where I want to go in and touch on some of the highlights or outliers within the tests. So this is the help desk. Help desk user was compromised and had the exposed delta of 90%. On the left-hand side, this is the reporting out of Splunk. This is visualization out of Splunk, I should say. This is the visualization out of Infection Monkey. This is why I did not use the Infection Monkey as my sole source of data analytics. This can be easily organized. We can see that every single system was compromised from every single other system, whereas here, I'm not really sure what's going on over here. All we know is that this was just bad. With the segmented scenario at the same time, we only see a foothold system was compromised. We can see with Infection Monkey reporting, other systems were discovered, but they were not compromised. That's what the yellow path means here. Why did this happen? Well, help desk user is an admin user in all of the desktops within the environment. But help desk user does, just because they're help desk user coming from a help desk system, doesn't mean they should be able to access all of the desktops in the environment using WMI protocols. Doesn't mean they should be able to access SMB within all of the desktops on the environment. If we're sharing files, so help desk sharing files with their end users or trying to get files across the systems, they should be using their file servers, their central points to distribute those files. And this is exactly why a single system was compromised, which was only the foothold within the environment. Help desk user doesn't have admin rights on their file servers, so file servers are not compromised or not at risk. Whereas here, our entire desktop domain is compromised. And honestly, if this was the real scenario, I'm sure they would have been able to scrape some other credentials of those systems. So this is the worst case scenario. This is what every single IT person in the world fears to no end. That's your domain user compromised or domain admin user. This scenario, the idea behind this scenario is that the HR user is compromised initially, but then domain admin credential was cached in one of the HR desktops, and the malicious user was able to retrieve the credential using Mimikatz and spread through the domain controllers or through the rest of the infrastructure. Again, on the left-hand side, this is the representation of what happens when a domain admin is compromised in a flat or unsegmented or uncontrolled environment. On the right-hand side, we can see the Monkey Island is my command and control center. It compromises the HR system, and then it's only scrapes the domain admin credential from this HR system, and then it's only able to reach the file servers directly and the domain controllers in the backend. Why is that? Because the only protocols that are exposed to the HR user or to the HR system with the domain admin credential are going to be our SMB and WMI, and not even WMI. There is no reason why HR users should be talking to our file servers over WMI or WinRM. SMB, Windows file sharing protocol, not the most secure thing in the world, so that's going to be a fairly easy compromise. That's exactly what happens here. So our HR user gives up the domain admin credential to our attacker. File servers are compromised using SMB, and then the domain controllers are compromised using SMB. Again, if you look at the delta is one of the larger deltas. It's 80% delta between the segmented and not segmented. But at the same time, if your domain controllers are compromised, recovery is still going to be really bad. And honestly, I don't see how the remainder of the environment is not going to be compromised given enough time. So this was another test or another scenario I want to go over because it shows the importance of how complex the attack path is. Again, on the left, this scenario shows help desk user was compromised, and then the database user credential was scraped off of one of the help desk desktops or one of the database admin desktops. Left-hand side, again, everything is compromised, single jump across the board, open network, there is nothing really to control it. But on the right-hand side, in the segmented test, we can see the Monkey Island went over into the help desk user, then it was able to spread from the help desk user onto the other desktops. From the other desktops, it was able to scrape the server admin credential from the server admin desktops, and then was able to compromise the database servers. Database servers from the desktops of the database admins. Why is this important? Again, this is an automated test, so it's really kind of dumb and just scanning the networks. In a real life scenario, especially if you have a less than advanced persistent threat in your environment, chances are they're going to compromise a couple of desktops. They might find these database servers, but they could potentially fail to find the credential cached in one of these systems. Or they might not realize that these are systems of database admins. They might not realize that they're looking for database servers at this point. So complexity of a path matters. In this scenario, the exposure delta was only of 5% because the exact same number of systems was compromised. But we can see because this path was quite a bit longer, I shouldn't say quite a bit longer, the whole environment is fairly small. But because it did take an extra 2 jumps to reach the actual critical systems, your database servers, it does increase the complexity of that path and does give us some protection. One other thing, again, we're going back to that IDS, IPS. If we have the IDS, IPS enabled in the environment with the drop rules enabled, every single one of these compromises was setting off so many bells and whistles in my environment that it's not even funny. I mean, my alert counter was just going up and going crazy. If this was set to block the compromise, it would have stopped probably at this level right here. It would have never gone past it. Again, those are big ifs. You can never rely on a single control, and that's exactly the reason why I always say defense in depth is really your best key across all systems. So the zero trust takeaways. Zero trust architecture. This is actually after I conducted my experiment. After I was playing around for it for a while, I came across this paper by Naridin Basta. And Naridin Basta done something very similar, but he used a mathematical model to evaluate breach impact mitigation of microsegmentation, or how he called it, towards a zero trust. Surprisingly, not surprisingly, his mathematical model showed breach impact mitigation of zero trust architecture, or microsegmentation specifically, is between 60 to 90%. And that's exactly what my practical experiment showed as well, where we had the average of 60 with a median of 75%. Increased complexity of lateral movement through the environment. This one is really difficult to capture because, again, if you have a script kiddie going through your environment, they're not going to be able to. The more complex the path is, they're not going to be able to move through it very easily. If you have nation states going after your environment, complexity is a little bit of less of an issue for them, but it also gives us more time to catch them. It gives our tools more time to detect them and set alerts off. Lower the attack surface. So it's not even just preventing the lateral spread in the environment, but it's also having that initial foothold into the environment. The zero trust architecture does prevent callbacks to command and control centers if it's properly deployed. So even if a system is compromised within your environment, it's very possible the attacker will never know that it was compromised, therefore never actually continue with their attack through the environment. If it's an automated tool, it might still spread, you might still get ransomware. But at least the attacker doesn't have foothold in the environment, and it's more difficult for them to establish it. And then last but not least, and this is in highlighted bold, because defense in depth is really needs to be implemented across the board. Defense in depth greatly increases effectiveness of our zero trust architecture. Easy example is IDS, IPS. I keep going back to it. Another example, and I pointed out right here, is every single one of these scenarios I was testing, the idea or the reliance was that the attacker compromised somebody less cybersecurity educated or cybersecurity savvy, compromised their system first, and then was able to scrape a credential off of the systems. if you have defensive depth implemented and you're not allowing caching passwords or caching credentials on your local desktops, a lot of this attack vector is going to be nullified essentially. So we're going back to defense in depth is really key at defending all of our infrastructures. And that is it for the presentation. Any questions?
All right, you make it easy for me. Just offer, please, your first name and your question.
Darius Hernandez. So for someone that lives, breathes zero trust architecture, NIST less than 2 weeks ago just came with 19 ways to help build zero trust architectures. What are your thoughts? Are they helping? Are they hurting? 19 to me seems exorbitant. And from a GRC perspective, controls perspective, I'm a little bit worried about those 19 ways.
So from that perspective, so I don't know if you saw NIST 853 Rev 5 included another 20 controls that are specifically for zero trust architecture. So as far as the recommendation, the 19 ways, to me, they're guidelines. This is what should be done. I know 853 is less of a should and here's how you're gonna do this. But that's to me what the guidance are. Zero trust, again, it's not a tool, it's not a packaged thing you buy. It's a architecture, it's a model, it's a framework. And from the governance perspective, I can see where governance, keeps us employed. That's all I gotta say.
Thanks. Any other questions? This is your.
It's available anywhere. I'm kind of driving the microsegmentation ZTA stuff in my organization now, and some of these numbers might be useful for me in the future.
Sure. On my LinkedIn, I actually have a small article posted with the content derived for these slides. And then there's also a link to a research paper that actually has all details as well as scripts and everything else I've used to build it.
Very cool. Thank you.
And if all that should happen to fail, we also are recording this, and you'll be getting a notice from BSides saying when the recordings are available. So you have a lot of different ways to get it.
Thank you.
Yeah, that's exactly why I actually kind of thought of this topic in general, because zero trust architecture is expensive to implement. So when you come to your budget planning meetings and you're like, I want $20 million. They're like, nope. But that's exactly why I went through this exercise.
As someone who suffers through research, I appreciate what you've done, because if you do research, it is suffering. I'm sorry, right? Would you agree?
Yeah, the research part is fun. The writing part is not so much.
All right, fair enough. Yeah.
So building out infrastructures, planning research is actually extremely rewarding.
Oh, yeah,
Writing
can be
reports
fun,
is a little
yeah.
dull.
Yep, and I'm about to write my next research paper, so I know that. That's the suffering. So thank you. I do appreciate that. Please, everyone join me in thanking Alex. Appreciation for this. Thank you very much. We have a few minutes. If he wanted any one-on-one questions, we, I think, are starting our next session at 4:25. So that'll be our final session of the day in here. Thank you.
Yeah, let's work your bridge out here, Sean. Good to see you. Great presentation, dude. Good to see you.
Very cool. I'll definitely be messaging you on LinkedIn.
Yeah, and LinkedIn, they share all the information.